Hi, today we are looking at the limits of logarithmic and exponential functions. So for this, it's important to understand our graphs of these functions. So if we have, for example, y equals e to the power of x, we can see that if we look at our limit as x goes towards negative infinity, so to the left side of our graph of e to the x, then that's just going to equal 0. So that matches our horizontal asymptote. However, our limit as x goes towards positive infinity of e to the x would be positive infinity. Now, on this graph, we'll look at our limit as we approach this at vertical asymptote. So our limit as we approach 0 from the positive side of natural logarithm of x, we can see it goes down towards negative infinity. Now we don't actually have a limit as we approach on the negative side because our graph simply does not exist on the negative side. So we also will have one of our limit, and that's as we go towards positive infinity. So we also have our limit as x goes to infinity of natural logarithm of x is just going to be positive infinity. Now, understanding these patterns can help solve some simple questions. So for example, evaluate our limit of 5 to the power of x as x goes to infinity. We know that essentially simplifies to 5 to infinity, which would be infinite. Or if we have our limit as x goes to infinity of 2 to negative x, that would be the same as 2 to the power of negative infinity. That's essentially going to take us to 0 because that's the same as saying 1 over 2 to infinity, which would be 0. The next one, we have our limit of 1 over 4 to the power of tan x as x goes to pi over 2. From the positive side. Now, if you recall your graph of tan, if you're looking at it from the positive side, so our graph of tan we know is going to look something like this. Now this dashed line here is pi over 2. If we're approaching it from the positive side, we're down at negative infinity. So what we're actually looking for in this case, or what we're going to encounter, is going to 1/4 to the power of negative infinity. Now that would be the same as saying 4 to positive infinity, which is infinite. Okay, so next we're going to look at limits in determinate form 1 to the power of infinity. And essentially that's part of Euler's number. So E is equal to the limit of 1 plus 1 over x as x goes to plus or minus infinity which is the limit of 1 plus x to the power 1 over x as x goes to 0. And it gives us this number that repeats on and on forever. So we want to evaluate our limit as x goes to infinity of 1 plus 5 over x to the power of x. Now, from this previous page, you can see that these limits are very similar. Before I realized I forgot to put this exponent here. So these are the same except for these get swapped and our limit changes from infinity to 0. So we're going to utilize that to help us solve. So if we have something that's 1 over x, we'll typically change it to x to the power 1 over x and go to 0. Or we'll go the opposite way, and we'll go from x to 1 over x to the power of x and go to infinity. So if we have our limit as x goes to infinity of 1 plus 5 over x to the power of x, that's going to equal our limit of, we want to change it to a form that's on the previous page, of 1 plus 5 over x. But instead of going to the power of x, we want to set it up like this, where if it was 1 over x, it's to the power of x, or seeing we're going to infinity, so therefore we want it to the power of x. So therefore, in this case, because it's 5 over x, we need to do it to the power of x over 5. But to make this match this, because for some reason we're dividing by 5 here and we don't want to get rid of it, we would do the whole thing to the power of 5, because essentially those would then cancel out. Now we know that if we have 1 plus 5 for x to the power of x over 5, because these match by reciprocals, that's just going to give us Euler's number. And then it's going to be to this exponent, so that's e to the power of 5. That's when we've got our limit as x goes to infinity of 1 minus 4 over x to the power of x. So we want to change this so that we've got x over 4, so then we can change it to Euler's number. So this would be our limit as x goes to infinity of 1 minus 4x, or sorry, 4 over x to the power of x over 4 to the power of 4. So this part here is equal to Euler's number, and then it's to the power of 4.